This rover, ESP32. This boat ripping across the water, same chip. And this four-legged guy that I am way too proud of, yep, ESP32. And here's the part that breaks people's brains. The controller I'm driving them with, also an ESP32. Here's the wild part. That brain costs just a few bucks. It has Wi-Fi, it has Bluetooth. It's got more horsepower than the Arduino most of us started on. And honestly, for a huge number of mini robots, it's the only controller you'll ever need. Welcome to minirobo, the series where every episode we take one off-the-shelf part and I show you exactly how to build with it. Today is episode 1, and we're starting with the heart of the whole channel. By the end of this video, you'll know what the ESP32 is, the bare minimum to get it running, the surprisingly fun story of where it came from, and a bunch of stuff I really wish someone had told me. Let's get into it. The board I build with is the ESP32-C3 SuperMini. The ESP32-C3 chip on a board, barely bigger than a coin, with a USB-C port and a row of pins down each edge. The chip itself is made by a company called Espressif. It's tiny, breadboard friendly, and just a few dollars. What does it actually do? Well, it's a microcontroller, a tiny computer that runs one program on loop forever, controlling stuff in the real world. The ESP32-C3 has a single core RISC-V processor running around 160 megahertz, a pile of memory, and built-in Wi-Fi and Bluetooth low energy. Now that radio is the magic. It means your robot can be controlled from your phone with no extra parts. And the same radio has a third trick, an Espressif special called ESP Now. Two ESP32s talking directly to each other. No router, no pairing, no network setup, board to board, almost instantly. Remember that controller from the intro? That's exactly how it works. One ESP32 on the robot, one in your hand, talking ESP Now. We'll build one later in this series. Now, the bare minimum you actually need to use this thing. There are really only a few facts that get you from box on your desk to blinking LED. Number 1, and write this on your forehead. Just not literally, but this is really important. The ESP32 runs on 3.3 volts, not 5. The pins are 3.3 volt logic. Power it through the USB port, and the board handles the rest. But if you start wiring 5 volt sensors straight into it, you can hurt it. We'll come back to this. It's the number 1 beginner killer. Number 2, those numbered pins down the sides are GPIO. General purpose input output. Each one can read a button, read a sensor, or switch something on and off. A bunch of them can also do PWM, or pulse width modulation. That's the rapid on-off signal that controls motor speed and servo position. That's literally how your robot moves. Number 3, how do you program it? I use PlatformIO, a free extension for VS Code with a PIO command line if you prefer a terminal. You describe your board once in a little PlatformIO.ini file, plug it in over USB, and hit upload. The code itself is the same setup and loop Arduino-style code you may already know. And that's the whole on-ramp. Power over USB, talk to pins through GPIO, write code with PlatformIO, get an LED blinking, and you've basically already used everything you need to start building a robot. This sandwich, a board on top of a board, is what Wi-Fi on a hobby project looked like not so long ago. $40+ and a headache to use. Then in the early 2010s, a Shanghai company called Espressif dropped a chip called ESP32-C3, a tiny Wi-Fi module that cost just a few dollars, and the maker community completely lost their minds. Suddenly, cheap internet-connected projects were possible for everyone. But the 8266 had limits. Not many pins, single core, kind of quirky to work with. So around the mid-2010s, Espressif released the sequel, the ESP32. 2 cores, way more pins, Bluetooth on top of Wi-Fi, and the same can't believe it's this cheap price. More recently, they branched the family into cheap single-core RISC-V chips. And that's the ESP32-C3 in our SuperMini. The spirit of the ESP32 shrunk onto a board the size of a coin. It took over benches everywhere because it was powerful enough for real projects, cheap enough to fry without tears, and it landed right as the Arduino world was huge. Familiar tools just worked, and the company wrote thousands of libraries. Other companies built boards around the same chip. The SuperMini is one of them. The ESP32 won by being cheap and good and open, which is the most minirobo origin story possible. All right, the stuff I learned the hard way so you don't have to. 1. Back to that 3.3 volts. Tons of sensors and modules online are sold for 5-volt Arduinos. Wiring their signal pin straight into the ESP32 can damage that GPIO. Check the part's voltage before you connect it. This one mistake cooks more boards than anything else. 2. If your computer won't even see the board, watch this before you panic. Lights on, board dead. So many cheap cables are charge only with no data wires inside. The board powers up, but nothing can talk to it, and you assume it's broken. One cable swap, fixed. Use a known data cable and label it as a good cable. 3. Not every pin is equal, and on the SuperMini, you only get about 11 of them. A few are strapping pins, GPIO 2, 8, and 9, that the board needs at startup, so save those for last. When something won't respond, the wiring's often fine. You just grabbed a pin with a special job. Keep the SuperMini's pinout picture open while you build. 4. And this one saves robots. Don't run your motors off the ESP32's pins. The chip controls the motors, but it can't power them. A motor pulls way more current than a GPIO pin can give, and you'll get random resets or brownouts. Use a motor driver like a DRV883 with its own battery feeding the motors, linked below. 5. If an upload ever hangs at connecting, hold down the little boot button on the board while it starts uploading, then let go. Half of the My ESP32 is dead posts online are solved by that one trick. So that's the ESP32-C3 SuperMini. A few dollars, Wi-Fi and Bluetooth, single core brain barely bigger than a coin that's genuinely almost mini robots will ever need. One part and you're ready to build. And before you go, this week's 60-second challenge. Make the onboard LED blink SOS. 3 short, 3 long, 3 short. One catch to keep you honest. That LED lives on GPIO 8 and it's active low. Writing low turns it on. Sounds small, but it forces the 3 skills everything else builds on. Editing code, uploading it, and thinking in milliseconds. If you can blink SOS, you can animate a robot. Crack it, then tell me in the comments what tripped you up. Everything from today, the pins, the voltages, the gotchas, fits on one cheat sheet card, free, on the episode page at minirobo.io. It's kind of fun to say, minirobo.io. Next time on Minirobo, we give this brain something to move. We're getting into servos and how to make a robot that actually walks. If you want to follow along, subscribe so you don't miss it. All the parts I used are linked in the description, and drop a comment to tell me what you're building. I'll see you in the next one. Let's build something.